So, a very good evening to all of you. So, today we are going to perform one more experiment, and that is the application of a sinusoidal voltage source to the RL type of load. So, basically, as you know, that the RL type of load is the induction motor, whereas if you consider the RLE type of load, it is a DC motor. So, this arrangement, that is the sinusoidal voltage, then you are having the resistor and the inductor. The entire thing is drawn in the physical side, physical system. That is, you can see this is available in the SimScape, the sinusoidal voltage source. Now, if you just double click on it, you will be having the peak amplitude. Then you can also change the value of frequency. That is 50 hertz we have taken for India. Now, this will be given to the combination of a resistor and the inductor. The value of the resistor is taken as 1 ohm, and the value of inductor is taken as 100, that is 10 millihenry. So now I have already run this simulation. So we will try to obtain the voltage waveform and the current waveform. Now, if you want to measure the voltage and the current, so for that you will be having for that you will be having this RMS block. This RMS blocks are very important because the average value for the sine waveform is zero. The average value for the sine waveform is zero. So for that we have taken the RMS value of it, that is the voltage and the current. Okay. So now we have got this waveform. You can see that the circuit is inductive. The current lags the voltage by some angle, because the value which we have taken is 10 millihenry, which is very high as compared to the 1 ohm resistor. So we were discussing about the RMS value. So what we have done, this is the physical system, and after that we have connected a physical system to a Simulink converter, and then that value will be given to the RMS. This is the current side. For current, we are having the current sensor, and for the voltage, we are having the voltage sensor. Okay, so now this will be given to the RMS block. Then there will be two display blocks. Now, when you talk about the resistor and the inductor will be requiring some reactive power, because there are two power that is going to flow through a circuit, that is active and the reactive power, and its combination is called the apparent power. So, for the power measurement, you can see that the input side is V and I, and the output side is P and Q. The voltage is taken from the voltage sensor, and the current is taken from the current sensor. That will be given to this power measurement block, which is there in the Simulink library browser. So you will be able to get the value. You can see this is in watt and this is in VAR, that is volt ampere reactive. Now, you want to also calculate the power factor, because the power factor is not is now in this case is not unity. It will be less than 1. So, to calculate the power factor, what is the formula for that? Cos pi will be equal to active power upon apparent power, and apparent power, it is the combination of the active and the reactive power. So that will be the case. You can see here the u of 1, that is the first, that is P, and u of 2 is Q. So this is the active power upon square root, that is P square plus Q square. So u of 1 square, u2 of square. So this will be your power factor. So before that, we have taken a multiplexer, that is mux. And after that, to calculate the angle between the voltage and the current, because we want to estimate this angle. So yeah, I think this is coming around 70 to 70 degree. So for that, you need to have the cos inverse, that is a cos will be cos inverse. You need the value in the degrees, not in the radian. So for that, the gain value, okay, just a minute. The gain value is 360 degree upon 2 pi. This is required because, okay, you can see 360 upon 2 into pi. 360 upon 2 into pi. This is the gain value. So in this way, you can just easily uh, easily calculate the active power, reactive power, and the power factor, and you can also view the waveforms in the scope. This is all about the experiment number 7. I think you can easily perform the experiment. So there is nothing difficult in this game because yeah, the I will also have to mention here that electrical reference is required. So whenever you are using a physical system and whenever you are using a solver, that time electrical reference is very much required. This is equivalent to your ground. And for calculating the AC voltage, you need to have the continuous RMS measurement block. For the power, you are having the power measurement block. Then for the power factor, this is the thing. So before that, a multiplexer has been used. Multiplexer will be taking two variables. You can see that is the active power variable, then the reactive power variable. So this active power will be U of 1, reactive power U of 2. So write the equation and get the values of the phase angle in degrees. That is the power factor angle. This is all from my side.